Now let's get used to the terminology that we use in these questions. First thing is, we have something called as a sequence. So a sequence is nothing but any order in which you write a numbers, right? So let us say, I'm just taking an example, 0, 2, 4, 6, 8, 10, so on. It is a sequence, right? And after finding the sequence, then okay, let's talk about the sequence for a bit. Let's try to number each number in the sequence. Let us say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? Or let's start from 0, instead of starting from 1, 2, 3. It will make sense. Let us say the rank of this one or the number of this one is 0, 1, 2, 3, 4, 5, so on. Now let's call it as n. Now when n equal to 0, the sequence is having a number 0. When n equal to 1, the sequence is having a number 2. When n equal to 2, the sequence is having a number 4. Let's call it as t of n, something, t of n or f of n, whatever it is. Therefore t of 0 equal to 0, t of 1 equal to 2, right? T of 0 equal to 0, t of 1 equal to 2, t of 2 equal to 4, so on. So that is how you can map it. Now that is called a sequence. Got it? So after defining a sequence, we are supposed to have one more thing, recurrence relation. So what is a recurrence relation is, if you are able to write nth term or any term in this sequence as an expression or as a mathematical equation or a mathematical expression of the previous terms, then we can call it as the recurrence relation. So which means in this case you can observe one thing, t of n, which means nth term in this, is equal to t of n minus 1 plus 2. What does it mean? If you want to get the next term in the sequence, you have to take the present term and add 2, right? If you want to get this term, you have to take this term and add 2, isn't it? If you want to get this term, you have to take this term and add 2. If you want to get this, you have to take this one and add 2. So that is why t of n equal to t of n minus 1 plus 2. Now this is called as recurrence relation. So along this recurrence relation, something will be called as initial condition. So initial condition in this case is t of 0 equal to 0, right, and t of 1 equal to 2, right? And this one you can define for n is greater than or equal to 2. For example, if you try to put t of n equal to 0 here, if you want to find out t of 0, then what happens is, if you put t of 0, it will be t of minus 1, but minus 1 is not defined here. Therefore let's not define it for for 0, we can define it from 1 onwards, isn't it? So t of 1 equal to t of 0 minus t of 0 plus 2, which is nothing but 2. Got it? So what is it? A sequence. Sequence is nothing but a series of numbers. We call it as a sequence. And then after the sequence, we are going to define the recurrence relation. A recurrence relation is nothing but writing a term in this sequence as a arithmetic expression of previous terms in this sequence. Here I have used only one term, but in general it can be any number of terms, right? That is called as recurrence relation. Along with the recurrence relation, some initial conditions will be given, right? So what are initial conditions is, what is t of 0, what is t of 1, like that. Some initial conditions will be given, and in most of the cases these initial conditions we may not be able to derive these initial values from the equation. So such values should be given here. So in this case, t of 0 equal to 0 has to be given here, right? So the main aim of our topic is to find out what is called solution of this recurrence relation using the initial conditions. So what will be given? A recurrence relation will be given and the initial conditions will be given, and we are supposed to find out this solution, right? Solution of recurrence relation. Now what is the solution of a recurrence relation is any expression that satisfies the recurrence relation is called as solution of that. For example, in this case I am just assuming, I didn't tell you how to solve it yet, but then I am just assuming that maybe the solution of this one can be this. So what is the solution is, even though the recurrence relation is expressing a term as a arithmetic expression of previous terms, we don't want these terms, we want to express it purely in terms of n, that is called as solution, right? Now how do you know that it is the right solution or not? If it is the right solution for the given recurrence equation, then this solution should satisfy the recurrence relation. So how to satisfy it? Now say this, assume that this is the solution, this is right. Then what happens to LHS? LHS of this equation is T of n, right? See this, LHS of that recurrence relation is T of n, and according to the solution T of n is equal to 2n. Got it? What about the RHS? RHS of the recurrence relation is T of n minus 1 plus 2, right? Now what is T of n minus 1? If T of n is 2n, then what will be T of n minus 1? 2 into n minus 1, isn't it? Plus 2 is already there. Are you getting this? If T of n is 2n, then T of n minus 1 means in place of n we are supposed to put n minus 1. I am just substituting n minus 1. Then what do I get? The same thing, then which is nothing but again 2n. Now if you observe it, by using this term in place of T of n, if I use 2n, this particular term is actually satisfying this particular equation. Therefore this 2n, T of n equal to 2n is the solution of this one, which means if you want to get the nth term in this sequence, either you can go with this or you can directly go with this. By using a solution we can directly find out the an element in the sequence very fast, but if you don't, if you are using the recurrence relation, we might have to go through several steps, right? So that is how we solve it. So let's see some examples first. Again, I didn't tell you how to solve the recurrence relation yet. I am assuming that I know the solution, then I am going ahead. So let's see some examples. Now sequence, one sequence I am giving you is 1 3 5 7 9 11 so on. Now for this sequence you try to give me what can be the recurrence relation. So the recurrence relation can be, if you treat T of n, maybe if this is 0th term, this is first term, this is second, third, fourth, fifth, which means T of 0 should give you that. So it can be 2n plus 1, right? In case if you start this one as 1 2 3, then it can be 2n minus 1. Got it? So this is the recurrence relation. Then what about the initial conditions? So initial conditions in this case is T of 0 is equal to 1, and the other things can be computed accordingly. T of 2 can be computed. Therefore recurrence relation is valid for n is greater than or equal to 1. Now when n equal to 0, T of n equal to 1. Got it? This is also called as initial condition or base condition or anchor condition. So every recurrence equation is supposed to have something like that. Okay, now what should be the solution, or what could be the solution? What did I tell you about the solution? A solution is anything that should be satisfying this recurrence relation. So I am assuming that the solution could be, I have written the solution here itself by mistake. So what can I say? T of n minus 1 plus 2, the same recurrence relation, right? T of n minus 1 plus 2, T of n equal to T of n minus 1 plus 2, which means you go here, if you want to get this term, you take the previous term and add 2. If you want to get this term, you take this term and add 2. If you want to get this term, you take this term and add 2, right? Okay, now I am assuming that the solution for this one is 2n plus 1. I am just assuming. How do I know that? I didn't solve it yet, it is just my assumption, right? Or assume that someone has given you to test whether this is a solution to this recurrence relation or not. How are you going to test it? The same method. Take LHS. So what is the LHS of the recurrence relation? LHS is T of n. So T of n is nothing but 2n plus 1. And what about RHS? Now RHS is T of n minus 1 plus 2, right? So what is T of n minus 1? If T of n is 2n plus 1, then T of n minus 1 is 2 into n minus 1 plus 2, because 2 is already here, and this is what I got from the T of n minus 1. Then what do you get here? 2n minus 2 plus 1 plus 2, that is nothing but 2n plus 1. Now if you observe it, both LHS and RHS are same, which means this particular solution is satisfying this particular equation. Therefore this is called solution of this equation given these conditions. Got it? See, one more thing, you might see that both of them are actually one and the same. So this equation and this equation both are actually one and the same, but then you got two different solutions, right? The reason is this one is having initial condition T of 0 as 0, and this one is having initial conditions T of 0 as 1. Therefore the sequences are different. Whenever the initial terms are different, then the sequences will be different, and so the solution must be different, right? So don't worry, we are going to solve lot of examples, you'll understand it. Now let us see one more example. Let us define a sequence like this. One sequence defined is 1, 2, 4, 8, 16, so on. Alright? And what about the recurrence relation for this one? So if you consider that this is 0th term, first term, second term, third term, fourth term, which means T of 0 equal to 1, T of 1 equal to 2, T of 2 equal to 4. If you consider it that way, then the recurrence relation is going to be T of n is equal to 2 into T of n minus 1, and T of n is equal to 0 when n equal to 0, and this one is valid for n greater than 0, which means n is greater than or equal to 1. So if you observe it, what I mean by this recurrence relation is, if you want to get a term in this sequence, you have to take the previous term and multiply it with 2, which means if you want to get this one, you have to take the previous term and multiply with 2. 2 into 2 is 4. If you want to get this one, take this one, 4 and multiply with 2. If you want to get this one, take this one and multiply with 2. Got it? Now let's try to guess the solution. I am guessing that the solution might be, I think you too can guess it. What is it? T of n equal to 2 power n is the solution. That is what I am guessing. I don't know whether my guess is right or wrong. How can I test it? Just try there. Okay, so try substituting it in. If this is the solution, it is supposed to satisfy the recurrence relation. Now what is the recurrence relation? Let's say LHS first. Now LHS is going to be T of n equal to 2 power n, and then RHS is going to be 2 into T of n minus 1, which is nothing but 2 into, so what is T of n minus 1? If T of n is 2 power n, then T of n minus 1 is going to be 2 power n minus 1, isn't it? Then it is nothing but 2 power n. Now if you observe it, LHS and RHS are same, which means this particular solution which we guessed is able to satisfy this particular recurrence relation. Therefore this is the solution of this equation. Got it? And so we can say that it is a solution. So what did we learn from this video? One thing is, there is something called as a sequence. From a sequence, a recurrence relation will generally be defined, and then initial conditions will be given. So in exam, they will be giving you these two things: what is the recurrence relation and what is the initial condition. Now using these two things, we are supposed to find out a solution. Now what is the way to find out a solution? We didn't discuss it yet, but then if given that something is a solution, then that is supposed to satisfy this recurrence relation, right? So in exam also, if they ask you for the solution, you can directly use it in the substitution method and you can find it out. You can find out that it is a solution, right? But anyway, we shall see how to solve it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs universities better than IITs. They have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.